Hello everyone. Today I am online to talk to you about mruby machine. Let me introduce myself. I am Hasumi from Matsue. I love sake, coffee, curry, and soba. I usually write various applications and I am sometimes known as a microcontroller. Anyway, please check my Twitter account because I will trade some additional information on Twitter while this video is being streamed. This is our company, Monster Lab. We are a worldwide development firm including Matsue. Please let me know if you are interested in working with us. Okay, let's start. Chapter 1. Background of my project. According to the FAQ page of MicroPython, generally, we keep minimal of configuration of MicroPython under 80K of ARM thumbed code, which includes compiler and interactive prompt. That means a Cortex-M microcontroller with 128 KB of flash, which means ROM, can host a minimal version together with some hardware drivers. Regarding RAM usage, 8 KB is minimal amount to run simple scripts. As Python is interpreted high-level language, the more memory you have, the more capable applications you can run. The reference MicroPython board, PyBoard, which has 128 KB of RAM. On the other hand, at our end, flashing mruby application into 128 KB ROM and running it on 128 KB RAM are apparently both difficult. mmrbc is a smaller implementation of mruby virtual machine, though it doesn't have a Ruby compiler, so you have to compile the Ruby script into VM code before embedding. I admit to say, MicroPython is really strong, but I don't give up. Let's make something that doesn't exist yet. It will be a small mruby compiler. By the way, our target microcontroller is PSOC5LP, which has ARM processor, 64 KB RAM, and 256 KB ROM. I think it will be comparable enough if Ruby compiler runs on the microcontroller. Now, I will show you a quick demonstration. You can see the PSOC on the left window. Right window is a terminal emulator connected to PSOC with serial cable. I'm starting PSOC. Then type some Ruby code such as enter. Hey, hello world. Nice to meet you. Then I will make an instance of LED class like then class of LED is, of course it is LED. Now I can turn on the LED like this. Look at the PSOC. Yay! And I can also turn it off. Congratulations! You have just seen that an mruby compiler and a virtual machine run together on PSOC. Chapter 2. Now we're gonna take a look at terms and tools. mruby is mruby, as you know. mmrbc is a command line tool of mruby compiler. It's a part of mruby. mruby/c is yet another mruby which is smaller than the original mruby. As I said before, mmrbc is just a virtual machine and doesn't contain mruby compiler. So we usually use mmrbc to make VM code for mmrbc. There are very new words on this page. mmrbc is the key product of today. It means mini mruby compiler. Then I call the combination of mmrbc and mrbc. It is mmruby. mruby machine is the title of this talk whose technical stack is illustrated on the next page. We will be able to deal with almost everything about microcontroller by using Ruby. Today I'm focusing on the compiler though. Other stuff like shell and interrupt are also very interesting as well. I hope I can have another chance to talk about them in the near future. Next, I need some cross-compilation tools for ARM because the architectures of my host computer and the target controller are different each other. We use ARM non-EABI tools to build binaries for ARM processor. ARM obviously means ARM architecture, and NUM means without OS. You can also say bare metal. EABI means Embedded Application Binary Interface. So now you know these tools are what you need. I use 3 different kinds of tool chains for my project. One is normal GCC, which is a daily C compiler. Second, I sometimes build a binary for ARM Linux to make sure I didn't make a bug which appears on only ARM architecture with this. You can also use GDB to debug with QM. It is a machine emulator. And the last thing is non-EABI GCC. And it is the tool for making final executable of PSOC, as you are already familiar with. By the way, I pushed a Docker image for you. Feel free to use it. The last thing of this chapter is C library. There are various C library out there, such as GNU C library is the most popular one though. I don't recommend you to use it for microcontroller because the code size will be too big to install. In this case, you can use New Lib series instead. They are designed to be small in return for somewhat abundant something like performance or runtime security. Now we are diving into mmrbc, mini mruby compiler. It's the repository of mmruby including mmrbc. Please check it. These are the features of mmrbc. It doesn't depend on mruby nor mrbc. mmrbc depends on only libc like glibc or newlib. mrbc can be integrated with both mruby and mrbc. You can easily build it not only for ARM architecture but also many other architectures. And it is small, of course. The details are to be mentioned later though. You can install it into 256 KB ROM and runs on 64 KB RAM, as you saw on the demonstration. mmrbc uses Lemon as the parser generator instead of Yak or Bison. Lemon is originally a parser generator of SQLite. I know almost all of you love a topic about parser generator, right? So I speak a little more about it. What I will say from now is what I learned as long as I could, so please correct me if I am wrong. LALR means look ahead, left to right. It is a name of the theory to parse. It is sometimes considered, I think, that Yak and Bison are almost the same. But there are several differences between them, things like Yak is non-reentrant, while Bison is reentrant and thread safe. And Yak has parser called Lexa style, while Bison has Lexa calls parser style. But you can also select all the Yak style in Bison. Lemon is reentrant and has Lexa calls parser style. It is modern style of parser generator, I think. In Yak style, the compiler calls YYParse function, which is generated from parseY by Yak. Inside that function, YYLex will be called in order to obtain next token. Then implementation of YYLex is all up to you, basically. And now you can generate final VM code with the syntax tree which YYParse made. On the other hand, the Lemon style, you would make a loop to tokenize the Ruby script. After getting a token, you call parse function, which is generated from parseY and Lemon. Then you can generate VM code as well. To summarize Lemon, it is also LALR parser generator. It is a reentrant Lexa calls parser style. According to the document, it is faster than Bison, but I don't know if it's true. And according to Mats, actually Mats told me that code size will be smaller than Bison. That's why I use Lemon instead of Bison. And then, although I don't have enough time to explain, grammar syntax of parseY is different from Bison. This is the official page for more details about Lemon. Please check it later. The final chapter, how smaller than mmrbc. The only thing I have to realize is small footprint in terms of RAM and ROM. Now is that time to compare. First, we are going to check RAM consumption. In this chapter, I use mmrbc branch of mruby to compare with mmrbc, which I wrote. To make the comparison simple and easy, I built mrbc and mmrbc as binaries for 64-bit Linux. Both of them internally use glibc and free in order to be analyzed by Valgrind. Valgrind is a toolset that helps with doing things like profile memory, or detect race condition of multi-thread. Analysis command looks like this. We also use msprint command to see the result of massif. Here's a case 1. Put hello world contains one functional call which has one argument without parentheses, as you see. Output is obviously hello world. This is the result of mmrbc. Massif shows you a transition of memory usage in this graphical shape. It tells us that mmrbc used 157 KB RAM to compile Hello World. On the other hand, my compiler mmrbc used only 11 kilobytes of RAM. I believe that you are clapping now. Thank you. In case 2, we're going to compile a little bit larger script. This is the result of that script. And mmrbc used 162 KB. mmrbc used 53. It turns out that mmrbc seems to have a good chance to run on one-chip microcontroller, I think. But at the same time, I think I still have to make improvement of memory efficiency. By the way, the script of case 2 also demonstrates what syntax mmrbc can deal with, such as assignment, constant, method call with parenthesized argument, array, and the assignment of array, and hash literal, symbol, string literal, and how can I say, syntax sugar, which makes array of string, and hexadecimal, unary operator, keyword true, and interpolation of string, and binary operator. My compiler can compile this syntax as of now, though I still have a lot to do, to be honest. Please check this roadmap if you are interested in. Now I will finish my talk by showing a code size comparison. These are the application code code files, what I demonstrated at the beginning of this talk. Then you can use size command to estimate how much ROM will be used. Text section is a machine code. Data section contains variables which have initial values. BSS section shows a RAM size, so the total of text and data will be the size of ROM consumption. Apparently, I still have some margin to implement more syntax for PSOC 5 LP, which has 256 KB ROM. Here is the summary of my talk. First, mmrbc is a mini mruby compiler. VM code generated by the compiler runs on both mruby VM and mrbc VM. It is still incomplete regarding syntax and memory efficiency. mmruby machine is an integration of mmrbc, mmrbc, shell, and hardware drivers. I hope that the shell and drivers, peripheral drivers, I can also say so, will be the topic next time. That's about it for today. Thank you so much for listening. I always appreciate the RubyKaigi organizers. Thank you all.